here we are. We're going to continue with section 9.4, graphing linear functions. So, graphing a linear function in a coordinate plane can give us a visual understanding and help us to understand some of the characteristics of a certain function. Some of us may be able to picture things a whole lot better by seeing a graph or seeing a picture of some sort. First, let's review though these functions. Okay, here is your relation A, and these are the ordered pairs or the set coordinates for this relation. And we know that the x's are the domain and the y's are your range. Now, it's asking you, are these following relations, is this relation a function? And what makes a function? A function is when you have for every one x, there is exactly one y. None of your x's are repeated here. They're all different, 1, 2, and 3. So then, yes, this is a relation. This is a function, okay? Relation A is a function. Here I've got relation B, and is this a function? Well, let's take a look. We've got 2, 4, 2, and 5. Well, the 2 is repeated, isn't it? So then this is not a function, okay? A function means that all the x's are different numbers like this one here, 1, 2, and 3. But here, because we have 2, 4, 2, 5, the 2 is repeated, so therefore it is not a function, okay? If we have this equation, f of x is equal to 2x plus 1, we want to find f of 2. That means we're going to take the 2, plug it into x, and plug it into this equation, and see what we get, okay? So 2 times 2 here, that gives us 4, right? 4 plus 1 gives us 5. If f of negative x, or negative 2 here, this means 2 times negative 2, okay? And what does that give me? Negative 4. So negative 4 plus 1 gives me negative 3. If we plug in 0 for x, okay, that means 2 times 0. And 0 plus 1 is equal to 1, right? So there's f of 0 is equal to 1. Let's say we use 1/2 for x, f of 1/2. Plug it in for the x value. So 2 times 1/2, the 2's cancel out, don't they? Because this is a fraction. 2 times 1/2 gives me 1. So 1 plus 1 is equal to 2. A linear function is a function whose graph is a line. Such an equation contains no more than 2 variables expressed only to the first power. So your x's, your y's, your k's, or l's, or m's, those are all to the first power. Nothing squared, nothing cubed, or 4th power, 5th power, and so forth. Notice here, to help you remember this, linear function. Linear, line, comes from this word linear, okay? And so that will hopefully help you. The graph is going to be a straight line in a linear function. Let's take a look at this example now. Okay, you're given this ordered pair, negative 1, 2. Okay, this is asking you, does this ordered pair fit in this equation to make it a solution? Okay, so where's my x? My x is negative 1, right? So I'm going to plug that in for x. And then the y is 2. Does this equal? So 2 times negative 1 plus 3. Negative 2 plus 3, does that equal to 2? No, because this becomes 1, right? 2 does not equal to 1. So therefore, this is negative 1, 2 is not a solution. Now, here's another example. Let's say we have 2, 7. Is this a solution for this equation? Y equals 2x plus 3. Well, you're going to plug in 2 for your x. Okay, so you have 2 times 2 plus 3. Does 7 equal to 2 times 2 plus 3? 2 times 2 becomes 4, right? 4 plus 3 equals 7 equals 7. So yes, this 2, 7 is a solution. And there you have that, okay? Okay, now it says find 3 ordered pairs that satisfy the equation f of x is equal to x minus 4. First of all, I just wanted to put a side note right here, okay? F of x means y, the y value, okay? So f of x is the same thing as saying y. You might be asking, why do we say that then? Well, f means the function of x. So this is called a function, all right? Now, you would make a chart for this function and find 3 ordered pairs, okay? That means you're going to select 3 values for x, plug it into the equation, and then find your f of x value, okay? So here is your x column. Here is the function column, this equation right here. You put that in the middle column. And then your final answer is the f of x, or the function. Or if you still need to think of it as the y value, that's the y's right here in this column. So in other words, the x, you plug it in to this equation and it equals f of x right here. Now, okay, your answers are going to be different, okay, because one student may choose a different set of numbers from another student or from me, okay? Let's say we have -2, 0, and 2, okay? -2, I'm going to plug that into my equation, x minus 4, okay? -2 minus 4 gives me -6. If I plug in 0, 0 minus 4, that gives me -4. If I plug in 2, I have 2 minus 4. That gives me -2. So then my ordered pairs are going to be -2, -6, and I write it right here. 0, -4, and I write it right here. 2, -2, and I'm going to write it right over here. And these are my 3 ordered pairs. 1, 2, 3, right here. Let's suppose that we are given this equation, okay? And say that the problem says using a table, so we're going to set up our table, find 3 ordered pairs that satisfy this given function, the given function rules right here, okay? So your answers are going to vary because, like I said, each of us are going to maybe choose some different numbers. One very simple number you can choose would be 0. Always choose 0 because that's an easy way to solve your equation very quickly. When you plug in -1, let's say we're going to use -1, 0, and 1. Okay, when you plug in -1, 3 times -1 gives me -3. 0 times 3 gives me 0, so this is 0, 0. 1 times 3 gives me 1, 3. So these are my 3 sets of ordered pairs, or 3 ordered pairs, that satisfy this equation right here, y equals 3x. Let's try this example now. This function, y equals x plus 2. So it says graph the function, but first you can make your table like we have right here, select values for x, solve for y, and then you can graph the solution, okay? So again, we're going to take -2, 0, and 2, okay? If I plug in -2 plus 2, that gives me 0, right? If I plug in 0, 0 plus 2 gives me 2. 2 plus 2 gives me 4, right? So now my ordered pairs are negative 2, 0, 0, 2, and 2, 4 right here. And then to graph this, I'm going to take these three pairs and I'm going to plot them on this graph with the x and the y's right here. Okay, the first one is negative 2, 1, 2, 0 right here. The next one is 0, 2, 0, 1, 2. The next one is at 2, 4, 1, 2, and then 1, 2, 3, 4. And then I can connect those dots, and there is my line for this linear equation. This is a linear equation. Here's my line. These were the three ordered pairs that gave me this line. Okay, let's say f of x is equal to negative 2x minus 5. Again, I'm going to make my chart. Okay, here's my x, negative 2x minus 5 right here, and then f of x. Then I'm going to plot select numbers negative 2, negative 1, 0, okay? So let's say I'm going to plug those in. Negative 2 times negative 2 minus 5. Negative 2 times negative 2 gives me positive 4, right? So 4 minus 5 gives me negative 1. If I use negative 1 times negative 2, this becomes positive 3. So 3 minus, this becomes positive 2. Negative 2 times negative 1 is positive 2. Positive 2 minus 5 gives me negative 3. Negative 2 times 0 now, if I plug in 0, minus negative 5. This becomes 0, doesn't it? So then my answer is negative 5. And then here are my ordered pairs. Negative 2, negative 1, right here. Negative 1, negative 3, right here. 0, negative 5, right there. And then I'm going to take these 3 points, or 3 ordered pairs, and I'm going to plot them on my graph, okay? Negative 2, negative 1, 1, 2, negative 1. Negative 1, negative 3. So negative 1 here, down 3, 1, 2, 3. 0, negative 5, 0, and then 1, 2, 3, 4, 5. And then there's my 3 dots, or 3 ordered pairs, and I can connect the dots and get my line, and there's the graph for this function, negative 2x minus 5. And I have this line for this linear equation.